Hey students, this is the third of 3 installments on the idea of connecting linear relationships to budgeting. Right, in our first 2 installments, what we did was we learned how to construct a budget constraint given the fact that a consumer, a guy named Adam, can either go out to get food at a restaurant or go to movies. Right, and we gave him some income. Right, so we said every month he earns $40 that he can either spend on movies or food. Right, and given the prices of a movie or a unit of food, we said this was his budget constraint. So in order to construct a budget constraint, we needed to have prices of the 2 goods that we want to consume and income. So after we did that, right, we had a standard form budget constraint. We saw how to do that in video 1. And then in video 2, we took that standard form budget constraint and turned it into slope-intercept form to show that this number right here, this coefficient in front of this variable, is the opportunity cost of consuming food. All right, so how much food does the consumer have to give up? How many movies does the consumer have to give up when he wants 1 more unit of food? And that coefficient tells us that given the prices that we face, right, every time Adam wants 1 more unit of food, he has to give up 5/4 of a movie. So in this particular exercise, what we want to do is take that information about the budget constraint, and learn how to construct a budget constraint on a 2-dimensional space. And to do this, we're going to break this up into 2 different parts. We're going to find the intercepts. So the first step we're going to do is learn how to find the intercepts. The second thing we're going to do is connect those dots and understand that the slope of that line tells us what the opportunity cost of a good is. So the way that I'm going to do this, I'm going to have the quantity of movies on the y-axis. I'm going to have the quantity of food on the x-axis. You can change these around if you want. That's not always the case, but in this particular case, if you wanted to have the quantity of food on the y-axis and the quantity of movies over here on the x-axis, that'd be perfectly fine. I'm just going to do it this way because I want to. And in step 1 here, what we want to do is find the intercepts. Now when we find an intercept, what we're doing is we're finding the maximum amount of either y or x that can be consumed or purchased or built or whatever we're trying to graph there. We're just trying to find a maximum. So for the first intercept, what we're going to do is answer the question, considering that Adam spends all of his money on buying food, right? And then that means he's going to go to no movies. What's the most amount of food that he can have? So we're going to use that budget constraint that we constructed in the first video. Right? We learned how to use that. And we're going to say, look, if m equals 0, what's f going to have to equal? Right? Because Adam's going to spend all of his income on food purchases. So if m equals 0, we can solve out for f equal 4. So Adam can have at most 4 units of food given his income and the price of food. Now similarly, to find the movie intercept, I'm saying that the amount of food that Adam's going to have is 0. And so Adam's going to spend all of his money on going to movies. Right? And when I do that, I get m equal 5. So on the graph, right, I've got 2 points. I've got the movies intercept. Right? That's the most amount of movies that Adam can go to. And I've got the food intercept. Right? And that's the most amount of food that Adam can purchase. Now in step 2, what I want to do is draw the constraint. Right? And that constraint's showing me where Adam's going to locate himself, given the fact that he's going to spend, so many dollars on movies and so much money on food. Now when I connect those two dots, right, I'm going to just draw a straight line. And straight lines in graphs mean that there's a constant relationship between x and y. And in this particular setting, that relationship that we're showing, the line is representing opportunity cost. So the opportunity cost of consuming a unit of food is 5/4 of a movie. It always is. That never changes. And that's why we can just draw a straight line between the movie intercept and the food intercept. So there's our budget constraint right there. And just to show a little bit further what this is showing, every time that Adam wants a unit of food, right? So he's going to buy 1 unit of food. He gets 3.75 units of movies when he does that. But if he increases his food consumption by 1, he has to give up 1.25 movies. And every time that he increases his food consumption by 1, he has to give up the same amount of movies. So that's why that's a straight line, and the slope of that line is negative 5/4. And remember, that's the opportunity cost of consuming food. So remember, a couple important things here. The slope of the budget constraint is equal to the opportunity cost of consuming food. Right? We get the opportunity cost of consuming good X by just taking the price of X and dividing it by the price of Y. Now, I've got some more practice that you want to run through. As economists, what we like to do is say, let's imagine a world in which the price of X or Y, right? So in the setting we looked at, the price of food or the price of movies changes. Right? So let's imagine that the price of food rises. What happens to the opportunity cost of food? Or what happens if we change income? Right? What happens if we give Adam a little bit more dough to go out and spend on food or movies? What happens to his budget constraint? You can explore these ideas in more practice, and I hope you found this to be helpful.